Hi, everybody. Can you show my presentation, please? Thank you. Hi, everybody. My name is Meaghan Fitzgerald. I'm DevRel at Avalanche. I work very closely with the platform engineering team. And I was heavily involved in the design process for ACP 77 and the next Etna DevNet upgrade. I'm here to talk about all the upgrades effects today, specifically on how managing validator sets has changed for L1s. But I want to start this presentation by recalling a conversation I had with one of our engineers when we were in the trenches. It was like 8 p.m. on a Wednesday in New York and in August. We were talking a lot about the upgrade and how this was going to be a huge paradigm shift for Avalanche, but he brought up to me that people rarely remember how goated the network already is, and like how we've worked really, really hard even before this upgrade, and there's so many amazing features of Avalanche because of it. So Avalanche has always been super passionate about building a multi-chain ecosystem. I think even if you're not very familiar with our tech, you kind of know that. We get compared to Cosmos a lot, but like we at Avalanche and at Avalabs understand that monolithic chains have very known efficiencies, especially for high throughput applications. Different networks simply have different needs, and different applications don't need to use all of the networking, the bandwidth, the compute enabled by certain EVMs or certain VMs, virtual machines. And we believe that purpose-built blockchains are the future and will be heavily adopted in the future because everybody deserves to have control over all layers of their blockchain, and it really pays to be very thoughtful about how you design your systems that you're running applications on. Because we believe so greatly in multi-chain networks, we get this massive throughput in our network. Like compared to any other network, we're doing like we're processing way more transactions. There's like way more gas used. A really good way to visualize this is if you look at Ethereum's daily gas used, pretty much since the end of 2022, they like hit their ceiling of how much gas could be processed, and then the price of transaction has skyrocketed. It's made building applications really difficult, not because Ethereum wasn't a pioneer who really introduced like programmable smart contracts and like smart contract applications to our network, but everybody really wanted to use this amazing virtual machine for their applications, and it just ended up being that because of the popular demand and because of the economics of how blockchains process transactions, they hit a ceiling, and they use about 110 billion gas per day since this time. On Avalanche, because we can deploy multiple chains, at a whim's notice or at a moment's notice, the amount of gas that our network actually has processed has increased since the beginning. And the average total gas processed by all the chains in our network that are public, by the way, this is just from the Subnet Explorer, so it doesn't include any chains that might be private or you might not have access to the information on, is about 1 trillion gas per day, just over all of the chains that are live on our network. So Avalanche has always been really passionate about L1 sovereignty, and that has been leveled up by ACP 77 and by Avalanche 9000. Because network creators have always been able to decide like who can validate their chain and how they're rewarded, which virtual machine they would like to use. It does not have to be the AVM, the EVM, the XSVM. Probably should not be the XSVM. Who can deploy smart contracts? This is with custom precompiles on Subnet EVM. If you've been familiar with those before, they're commonly used by enterprise parties. And then who can broadcast transactions, like if you need to run a private blockchain or a semi-private blockchain where you KYC certain individuals. And this is because the team at Avalabs has decoupled all the layers of the blockchain and made them very customizable. Avalanche also has always believed cross-chain actions must be seamless. I won't go into the nitty-gritty details, but Avalanche interchain messaging, or ICM, is a primitive for sending messages between chains, and it is native with any chain run on Avalanche. So, sorry, I just realized that I held the mic differently, and I can hear myself better now. And like any chain, any virtual machine can implement ICM. We also built Avalanche interchain token transfer, which is the interface for EVM to EVM communication. It just makes Solidity smart contract applications that are operating cross-chain a lot more, like it lowers the lift for engineers who want to implement that. And of course, finality is super fast and transactions are essentially verified in less than a second. But we wanted to level it up with ACP 77 and with Avalanche 9000. So we asked ourselves, how can we make it even easier to build purpose blockchains? And I think that the question we really asked ourselves was, how do we make Avalanche even more obvious as the choice for the place to build your own blockchain? And we were like, we should make it dummy cheap. We should just make it super cheap. You should be able to launch networks without having to think about the fact that you're going to need to pay a ton of money, and you're going to need to validate information from chains you might not necessarily interoperate with. Don't get me wrong, the primary network is extremely innovative and very useful for many applications, but for those building their own chains, there's really no need for them to have to sync all the historical data of all 3 chains on the primary network. And when the network was launched, like Gun said in the keynote yesterday, 2,000 AVOX was not very much money for you to have to put up in order to stake the network and validate, but today it's around 58K, and most L1s usually want to run at least like 5 validators, so it's kind of a lot of money. And one thing that people really never think about is the fact that to sync those extra chains, you got to pay a lot of money to Google Cloud or AWS or whatever cloud service provider you use just to store the state. So how are we going to make it cheap? We're going to remove 2,000 AVOX as the stake requirement. This just makes it easier for people to get going. We want users of all backgrounds and abilities to be able to do this, whether you're the richest financial institution in the world or a college freshman. We want to remove primary network validation. That one's pretty obvious, drastically reduces cloud costs. And the way that we will enable people to take advantage of ICM and the interoperability protocols is we will have them pay a very small fee to the P chain to validate their L1 instead. This ensures, people aren't just spamming our network creating chains, and it also ensures that everyone's incentivized to behave properly. So basically what you get is the hardware costs and requirements pre-Etna were very high and the stake was very expensive, and now you're basically just paying for the storage of your own chain and the monthly fee, or not the monthly fee, but the continuous dynamic fee to pay to validate your chain, which is 1.33 AVOX per month, so long as the total validators in the network stays below 10,000. If it goes above 10,000 target, it's just, it's pretty much a bell curve. It's like, the network adjusts the fee to prevent people from spamming and adding validators that are invalid or not doing anything, but it drastically reduces cloud costs. This is not to scale. I'm sure that would be way larger if I did this by any means of measure, but so now anyone can launch a chain with near instant finality, native interoperability, sovereignty, customizability. It's inexpensive. You're not rolling down to any other network, so you're not paying any costs that might be unpredictable in the future and variable costs. But a question that I get a lot, especially working as DevRel, is how has this change enabled this sovereignty? And so I'm going to walk you through the P chain and how they create new blockchains. So before Etna, the P chain was the place where you would create a subnet and you would add validators to start tracking that. So you issue a create subnet transaction. That creates a subnet ID. You issue a create chain transaction. You put all of your chain configurations in these transactions, basically, and you instantiate the genesis and basically just start setting things up. And then with the same key you use to sign those transactions, you could add and remove validators. Now, this was not necessarily sovereign because this is pretty centralized, and most of the chains on Avalanche today use this model. Where they add and remove validators by signing a P-chain transaction, the same P-chain key that was used to sign those 2 transactions. With ACP 77, we introduced this transaction on the P-chain called convert subnet to L1 TX. If you read the ACP, it's not called that yet, but we will call it that. And basically what this transaction does is it specifies a smart contract. This smart contract could exist on your L1, or it could exist on the C chain, or it could exist anywhere in the Avalanche network that is communicating with the P chain actively. And it basically removes the ability for this key, which had permission to send these transactions, to act at all. So once it's accepted on the P chain, these transactions become completely unusable, and like they essentially, the transaction types exist, but your subnet has no access to them. Instead, Avalanche 9000. Essentially, when you send this transaction on the P chain, this field here, address, is where you specify the address of your smart contract. You also add the blockchain ID of the chain where the smart contract was deployed. And this is where you will define how your chain adds and removes validators. So any protocol or any kind of configuration, I guess, that you want to define, logic you want to define for when somebody gets to join your network and when they get to leave, will be defined by a smart contract. So that means that, yes, like your rules for validation are completely unlocked. You can do NFT staking, you can do multiple chain staking, multiple asset staking. You can have someone like solve a puzzle online, and only if they provide the proof that you solved the puzzle that they could join. Like you can do anything you want because you have now unlocked like all programmability of Solidity. It also unlocks these other P-chain transactions, which are just used for the management of the validator set. And register L1 validator transaction is the one I'm going to walk through because it is the initial transaction you will send in the case of a proof of stake L1, where you yourself will like validate a new chain, the same way you would validate any other permissionless proof of stake network. So all of these transactions can only be signed, except for disable L1 validator. I'll get to that later, but all of these transactions for validator management can only be signed if you deliver a valid ICM message payload as part of the P-chain transactions payload, meaning that every validator currently validating your chain must sign a message with their BLS key, basically approving that this action has occurred and that this is a valid, I'm asking to validate your chain. The chain must approve that it happened and then communicate that to the P chain. These transactions cannot be signed by anyone with like higher permissions. These transactions cannot be signed without total permission of the network. So for instance, I want to register a validator on an existing proof of stake chain. I basically, and this is where I wanted to give the example where we specify a warp message payload as part of the payload for this transaction to add my validator to a network. I can come back to this. This is all of the example smart contracts for validator management that the team at Avalabs has produced. But I'm going to give the example for a proof of stake L1 and how they would add a validator. So the first thing you do is you'll go to the smart contract that has governed and defined the rules for validator addition, and you'll call their initialize validator registration function. If you've custom made a smart contract, this could have a different name, but the ones that we've defined at Avalabs are called initialize validator registration. Then the L1 that you are on should produce a warp message and send it to the P chain via ICM. If you've been with us for a while, ICM is AWM. They're just named differently now. You send a message to the P chain, and as part of the payload of register L1 validator transaction, you produce a valid signature. You include that in this transaction. Once it's approved, the P chain will sign a message, send it back to the L1, and then the smart contract will complete the addition of the validator by calling the complete function. So now you have completely obfuscated validator management away from Avalanche's primary network. And the P chain purely exists to ensure that you're doing this in a verifiable way, in a safe way, because the P chain is where all the nodes will store their BLS keys, the public key, obviously. It's the way that they produce the signatures for ICM. So going back to this nice, really adorable diagram I tweeted earlier, this is basically a suite of smart contracts that are the same team that developed ICTT, or formerly known as Teleporter, has made and are currently under audit right now. And we basically wanted to enable anybody who wanted to launch a chain but didn't necessarily want to write a Solidity contract to manage their validators to have this like openly available to them. So we have a proof of authority. There's plenty of institutions running chains on Avalanche, and there's plenty of people who are not interested in running a proof of stake network. So they would just use this smart contract. And the reason why they would want to use this smart contract and not just keep their setup now is because, as previously mentioned, chains that are currently running on Avalanche are running with the old, like they've added their subnet validator before. And subnet validators have to validate the primary network, and they have to stake 2,000 Avax. This contract will give them the same functionality they currently have, but it'll enable their validators to just pay that 1.3 Avax per month fee. And then there are plenty of people who want to run proof of stake networks for whatever reason. They already have a community, they're a game, and they want to let their players not only get loot boxes during the game, but also maybe get rewarded for staking and validating their network. And we know that there are some people who want to launch an ERC20 on C-Chain, on the Liquidity Hub, and use that as the staking token, and that there will be plenty of people who will launch a brand new network with no previously defined token, who are perfectly fine having the native token of that subnet be the staking asset. So these have all been defined. They all inherit Validator Manager, which is basically the abstract of functions that help initialize the validator set when the chain is created, and then also complete registration and end validation when a validator is removed. And I can go into detail if anybody has questions about this, but this has been produced on behalf of Avalabs for the Avalanche community because we know how much work it takes to make a chain. We know how much thought goes into that, and we wanted to just do our best to help lower the barrier even more and not put the onus of creating a whole new logic system on the community. So that's my presentation. Are there any questions? Yes. So the name of the GitHub repository for the changes I just talked about is just Avalanche Go. Yeah, it's all in Avalanche Go. And also, I forgot to mention that we have all the ACP 77 changes live on a DevNet. So you could think of Fuji, but even pre-Fuji, because we're still testing out some of the functionality. Running on a chain here, RPC endpoint, chain configs, everything is here. We running a faucet, running an Explorer. I've written multiple demos on how to deploy an L1. We're working on the demos for how to add and remove validators in the case of proof of stake. But Steven said yesterday that if you break the DevNet, he'll give you money. So yeah, well, but not a lot of money, but it'll be fun. And he'll give you mad street cred too. Maybe we'll tweet about you or something. But yeah, I highly recommend anybody to check out the DevNet if they're thinking of deploying an L1 or they're just looking to see how the flow has changed. Is there time for more questions? 7 whole minutes. Anything? Yeah?
Is there any proposal for zero knowledge proof of that technology for validate the chain instead of the zero knowledge proof like snarks, stuff like that?
As far as I know, there's no proposal open now, but the Avalanche community proposals, which is what ACP stands for, is an open repository. It's github.com/Avalanche Foundation/ACP. And we actually have multiple ACPs open for things related to what I talked about today. One of them including another ACP for another way to manage validators from Leo's partner, Gautier. It's ACP 99. It basically is another method of controlling the validator set embodied in smart contracts. Very similar to, I don't know. I don't know if this is really going to help me flipping through this, but to answer your question, no, not yet, but if you want to see that on chain, you should just open ACP. We're very, very active in that repository. Any other questions? Everything was super clear, really? I'm going to tell Luigi. Yeah.
Going back to your previous slide when we can see the different models this one. Probably something that would be interesting on our side for Suzaku is to mix both, So in our case, say we want to have an L1 that has like half of the validation weight be proof of authority and the other half be proof of stake. Will the validator manager abstract contract support that, or is it something that we'll have to do ourselves down in the schema?
So I think that's something you would have to do yourself. And the only reason I don't think it would support this is because this was really meant to be like the most bare bones implementation of it. And we assume that people would take our contracts and mutate them for their purposes. I have actually had a conversation already today about this 50% model versus the 50% POA, 50% POS. It's really interesting, and I'm down to talk about it afterwards.
Sure.
Anybody else? I have any questions? Could be unrelated to this topic too.
You had mentioned that you tweeted that. What's your Twitter?
Oh, my Twitter is Meg Fitzgerald. Meg with an A, MEAG. Blame my parents. And every Meaghan Fitzgerald, Meg Fitz, Meggie Fitz, everything was taken on Twitter, so it had to be that. Anybody else? Ooh. All right, thank you very much.